in this problem, we are adding these two fractions, these two rational expressions. Unfortunately, they don't have the same denominator. And remember, you can't add fractions unless they have the same denominator. Likewise, you can't subtract fractions unless they have the same denominator. So my first task here is to make the denominators the same. And the only way to know what to use as that least common multiple for the denominators is to first look at the denominators in their factored form. So I need to factor that trinomial. Well, that might possibly be one of the factors of that trinomial, might it not? Let's just see if it is. If there's 2x here, there'd have to be x here. If it's minus 3, it'd have to be plus 2 to give us the minus 6. And does that give us plus 1x under the O and the I of FOIL? Yes, it does. This is plus 4x minus 3x is plus 1x. So this denominator is a factor already of that denominator. That's kind of like if you were adding these fractions. 1/4 plus 5/8. Isn't 4 a factor of 8? So don't we use 8 as the common denominator when adding those two fractions? 8 is the multiple of 4. So we can use 8 as the least common multiple for 8 and 4. So this is what I want to use. This pair of binomials is what I want to use for my common denominator in adding these two fractions. So this fraction does not need to be changed. It's as if over here, if we were going to use 8 as our common denominator, which we would, we don't need to change 5/8 because it already has the common denominator we want to use. But 1/4 would have to be changed because it does not have the common denominator. Likewise, this fraction will have to be changed because its denominator is not the common denominator I want to use. Now, do you recall the thought process we use over here? Don't we ask ourselves, what times 4 would make our denominator into 8? That would be a multiplier of 2, wouldn't it? So we then have to multiply the numerator also by 2. 2 times 4 makes the denominator 8. 2 times 1 makes the numerator 2. I have to use the same thought process here. What's missing? It's x plus 2, right? Don't I have to multiply this denominator by x plus 2 in order to make it the new common denominator? Just like I multiplied this denominator of 4 by 2 to make its denominator the common denominator of 8? So I would have to multiply the numerator also by x plus 2. I can't multiply just one or the other, just as we had to multiply the numerator by 2 in this instance. So now I have to multiply the binomial x plus 2 times 3x, which means I'll have to multiply 3x times each of those terms. 3x times x gives me 3x squared. 3x times plus 2 is plus 6x. Now I have the same denominator, just as we do over here strictly with numbers. So now we can add the numerators. 2 plus 5 would be 7. Put that over the common denominator, 7/8. I'm going to do the same thing here. I will add these numerators and put the answer over the common denominator. 3x squared. There isn't a 3x squared. There isn't an x squared term over here to add, so that stays 3x squared. Plus 6x plus 3x more. That's plus 9x. There's no constant term here, so I just end up with plus 6. Plus a plus 6 is plus 6. And now, we would always look to see if we can reduce. We can't reduce 7/8, but we don't know whether or not we can reduce here until we factor that trinomial. So let's see if that trinomial is factorable. Well, this binomial couldn't be a factor of it, but maybe x plus 2 could be a factor. I'd have to have 3x, if it was going to be a factor, I'd have to have 3x what? Plus 3. And actually, I could have factored out a common factor of 3, which I probably should have done to make my factoring easier, but I think this will work for us. X times 3x is 3x squared. This is plus 3x plus 6x more, which is plus 9x. And sure enough, the x plus 2's cancel, and my final answer is 3x plus 3 over 2x minus 3. We could factor out that common factor of 3 if we wanted to, but we can also leave it in its multiplied form. So in order to add those fractions, I first had to determine what I was going to use as my common denominator, and then I had to build this fraction up to have that denominator, just like we've always done with fractions. You see the parallel process? Then we can finally, once we have the common denominator, we can add the terms in the numerator and then look to see if we can simplify our result by canceling common factors.